So we're going to look at the startup costs, which is 32x plus 80y is less than or equal to 1,280. And our space equation, which is 6x plus 24y, is less than or equal to 360. So what I'm going to do is solve each equation for y and put them in slope-intercept form. So I'm going to subtract 32x from both sides. So we would get right here, 80y is less than or equal to negative 32x plus 1,280. And then to get y by itself, we're going to divide by 80. So here, I would get y is less than or equal to negative, and I have to reduce 32 over 80. So I notice that 8 goes into both. So 32 divided by 8 is 4, and then over 10. But then there's a larger one because 4 over 10 can be reduced. So what I'm going to do is divide both by 16. So 32 divided by 16 is negative 2 over, and then 80 divided by 16 is 5. So that's negative 2 over 5x plus 1,280 divided by 80. So I'm using a calculator there as well. So that's 16. So we're going to use that in part 4 to graph this equation. And then same thing over here for my space equation. I'm going to solve that for y. So I'm going to subtract 6x from both sides. And we would get 24y is less than or equal to negative 6x plus 360. Then divide both sides by 24. And we would get y is less than or equal to 6 over 24. You can divide the numerator and the denominator by 6. And that would be negative 1 over 4x plus. And then I would take 360 and divide that by 24. And then that gives me 15. So we're going to skip 2 and 3. And then we're going to graph both of these. So if I'm graphing these, I'm going to put this in a positive plane. So this is going to be my x-axis. This is going to be my y-axis. And then I'm going to have to go up to 16. So what I'm going to do is just count by 5. So go 5, 10, 15, and then make 20. Then my y-intercept for this first equation is going to be 16. Now, to find my x-intercept, what I'm going to do over here is take the inequality, 32x plus 80y, and I'm going to plug in, remember, the x-intercept is when y is 0, so I'm going to plug in 0 in standard form, and then say that that is less than or equal to 1,280. So 80 times 0 is 0, so we get 32x is less than or equal to 1,280. Then divide both sides by 32, and you would get x is less than or equal to, and 1,280 divided by 32 gives me 40. So down here, I would count out to 40. So 5, 10, 15, 20, 25, 30, 35, 40. And I would put a dot. And then it's less than or equal to, so I can have a solid line. Again, this less than or equal to means solid. And then in slope-intercept form, if this graph is less than or equal to, I would shade down. So there is my solution. And you could verify that with Desmos. I just want you to be able to do that by hand. So the same idea over here, if I'm graphing y is less than or equal to negative 1/4 x plus 15, what I would do is putting that on here, graph that and go 5, 10, 15. And then to solve for x, what I would do is use standard form and plug in 0 for y. So 6x plus 4 times 0 is less than or equal to 360. 4 times 0 is 0. So I'm just going to get 6x is less than or equal to 360. Divide both sides by 6. And then I would do 36 divided by 6, which is 6, and add a 0. So x is less than or equal to 60. So then down here, you get 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and then 60. And then again, draw on my line. And then we need positive values for both x and y, so I would shade in this part. To see the solution region adequately, what I would do is graph with Desmos and see where they overlap. So where both are in here. So really what that would be is part of this from the y-intercept here of 16 and then 40. This part of it would be my solution region to both, which it's hard to graph by hand, and that's why technology works here. But you do need to make sure that you can put an equation, an inequality, into slope-intercept form and then graph. So you do not need to answer questions 2, 3, 4, 5, and 6. You can verify that with Desmos. So you can, that actually answers all of the problems that we need to do. And we will move on to the ready, set, go in just a quick second.